we have studied adsorption, the adsorbate, the adsorbent, and mechanism of adsorption. Now we will study the energy changes during adsorption, the physical and chemical adsorption. So here we are starting with Gibbs energy changes during adsorption. So we all know that attraction leads to loss of energy. So there is attractive forces between the adsorbent and the adsorbate, whether it is physical attraction or chemical attraction. So this leads to loss of energy. Energy is released in the form of heat. So adsorption is an exothermic process, that is delta H is negative. Then when particles of adsorbate get adsorbed on the surface of adsorbent, it restricts their movement. Particles are not free to move. This leads to decrease in entropy. So we can say that delta S is negative for this process. Now Gibbs energy, we can calculate the change in Gibbs free energy by the formula delta G is equal to delta H minus T delta S. Now we know that delta H is negative and delta S is negative. So for sign of delta G, the condition is it is negative only when delta H is less than T delta S. Types of adsorption. As told earlier, there are two types of adsorption, that is physical adsorption, also known as physisorption, and chemical adsorption, also known as chemisorption. Some examples are shown here, like gas adsorbed on charcoal, ink on paper, and rust on iron nail. So these are all adsorption. Physical adsorption occurs when there is physical attraction, that is van der Waals force of attraction between adsorbate and adsorbent. So physical forces are involved, so it is physisorption. Then chemisorption. Chemisorption or chemical adsorption occurs when chemical bonds are formed between adsorbate and adsorbent. These chemical bonds are strong chemical forces. So this is chemisorption. The reaction progress is shown here. You have studied this figure in previous chapter also, kinetics, that for change of reactants to products, some energy need to be supplied to the reactant molecules, that is activation energy. Then only they are converted to products because the transition state is of higher energy. So in chemical adsorption, some energy is to be supplied for conversion of reactant to product. Now some characteristics of physical adsorption. Lack of specificity. Lack of specificity means any gas can be adsorbed on any surface, though their extent may differ. Then low enthalpy of adsorption. Low enthalpy of adsorption because only physical forces are involved. No chemical bond formation is there. Reversible in nature. This means that the gas or substance adsorbed can be desorbed easily also. Means the substance can be adsorbed easily as well as it can be desorbed easily. Means it can be removed from the surface easily. Then nature of adsorbate. Nature of adsorbate refers to physical state or the substance used for adsorption. Generally, the substance having more surface area, there occur more adsorption on the substance having more surface area. So that is about adsorbent. Nature of adsorbate is generally, if we talk of gases which are liquefiable easily, they are adsorbed easily. Then it decreases with increase in temperature. Since only physical forces are involved, suppose a gas is adsorbed on a solid surface, if you increase the temperature, the gas will move away. So it will lead to desorption. So the cooler the thing is, the more will be the adsorption. So these are the features for physical adsorption. Then some chemical features for chemical adsorption. It is highly specific in nature. Why specific in nature? Because the chemical bonds are formed between two species only when they have affinity for each other. Then they have high enthalpy of adsorption, as shown in previous diagram, that high activation energy is required for conversion of reactants to products. Since chemical bond formation is there, so we can say that activation energy is higher, so there is high enthalpy of adsorption. Then irreversible in nature. Once a chemical bond is formed between adsorbate and adsorbent, it a bond breaks only when you supply high amount of energy, or it is only by a chemical process. It is not removed physically. So this is irreversible nature. Then nature of adsorbate. Again, adsorbate, if it has affinity for the adsorbent, then only it will form bond on the adsorbent surface. So then about temperature, as told earlier, the temperature is higher or more temperature is required because the reaction occurs with need of activation energy, which is to be supplied to pass through the transition state. So more it occurs more with increase in temperature. Very slow, not fast, because bond formation takes time after energy changes. Then it occurs at high temperature and pressure. So same reason, because activation energy is involved. Now both physical and chemical adsorption, if we talk of, the figure shown here is hydrogen gas is adsorbed on a surface. This is the surface of a metal. On metal surface, when hydrogen gas is brought near, it forms bond on the surface. Then another substance being adsorbed, this is some alkene. Then reaction takes place between these two adsorbed substances, and the product then gets desorbed from the surface. So this is how chemical adsorption occurs. This is how a catalyst catalyzes a reaction by adsorption. So this is explained here only. Metal adsorb hydrogen gas, it's adsorb, D in place of B. Metal adsorb hydrogen gas on their surfaces. The relatively strong HH sigma bond is broken and replaced with two weak metal hydrogen bonds. The pi bond of alkene interacts with the metal catalyst, weakening the bond. Then a hydrogen atom is transferred from catalyst surface to one of the carbons of the double bond, and then the second hydrogen goes to the second carbon, and later on desorption takes place. Here the differences in tabular form. So again we'll take the differences. It is because of van der Waals force, whereas this is due to chemical bond formation. It is not specific, but it is highly specific. Physisorption is reversible, chemisorption is irreversible. Physisorption is exothermic. This is again exothermic, but highly exothermic. More heat is released because bond formation is there. Then enthalpy is low, enthalpy is high. The low temperature is favorable. Here high temperature is favorable. This decreases with increase in temperature, whereas this increases with increase in temperature. No appreciable activation energy is there because no bond formation takes place. Here high activation energy is required because bond formation is there. Now last point you have to understand, multimolecular layers are formed because there is only physical attraction between the molecules of adsorbate and adsorbent. Once a layer of adsorbate is formed on the surface of adsorbent, still adsorbent can attract more adsorbate molecules and the different layers may be formed. But in case of chemisorption, only a unimolecular layer is formed because bond formation is occurring only between adsorbent and adsorbate. Once the surface of adsorbent gets saturated, no more adsorbate can occupy that place because no bond formation is there between two adsorbate molecules. So this is the difference between adsorbate, physical adsorption and chemical adsorption.